Welcome back. We're going to talk a little bit about functional notation today. We're used to seeing linear relationships such as f of x equals 4x plus 5. We've seen that before. We know how to understand this type of relationship. But what happens when we ask for f of negative 1? What do you do then? Well, this is saying we evaluate inside of the parentheses first. So f of negative 1 should be easy enough. That means every time we see an x on the right-hand side of this expression, we're going to substitute in negative 1. So this is going to be f times 4 times negative 1 plus 5, which simplifies to negative 4 plus 5, which is 1. So the output of f of negative 1 is 1. But this says to go back in with the output of f of negative 1 and plug it back into f. So now we have to do f of 1. And that's going to be the same function again, 4 parentheses 1 plus 5, 1 being the output of f of negative 1. What we get here is 4 plus 5, which ends up being 9. Okay? So that's the first thing. What else can we have? We can have two different functions and do a composition of that. So if we say, for a second example, f of x is now equal to x plus 5. And we have a second function, g of x, equal to negative x squared minus 5x. Okay? All right, so those are two functions. One is called f, one is called g. They're both in terms of x. But what if we ask for the composition f of g of negative 4? How do you do it? Well, we look at the inside first. G of negative 4. Let's do that. G of x is negative x squared minus 5x. G of negative 4 is negative. Everywhere I see an x, I replace it with negative 4. Minus 5 times negative 4. Now I can simplify the right-hand side. Negative 4 raised to the second power is positive 16, but then I negate it, so I have negative 16 here. And then negative 5 times negative 4 is a positive 20. Negative times a negative is a positive. This ends up being a positive 4. So g of negative 4 is 4. But this says find f of g of negative 4. So I got to take this output of g of negative 4 and plug it back into f, with 4 being sort of the input to f. So I say f of 4 is 4 plus 5. Where did I get the 4 plus 5? The output is 4. I plug it back into this x plus 5. And so f of g of negative 4 ends up being 9. Okay? F of g of negative 4 is 9. But what about if I reversed it and I did g of f of negative 4? Is it equal? So f of g of negative 4 was 9. But what if I did g of f of negative 4? What would that, is that equal to 9? So let's see. So I do the innermost first, f of negative 4. F is here, x plus 5. So I do f of negative 4 is equal to negative 4 plus 5, which is 1. And then I plug that back into g. So I say g of 1 is what? Is going to be, so I have negative x squared minus 5x. Okay. First I'll say g of x equals negative x squared minus 5x. Negative x squared minus 5x. But instead now I'll say g of 1 is negative parentheses 1 squared minus 5 times 1. And now I can simplify this. 1 squared is 1. This becomes negative 1. 5 times 1. Negative 5 times 1 is negative 5. So the output here is negative 6. So we figured out that f of g of negative 4 equaled what? 9. But g of f of negative 4 equaled negative 6. So they are not the same. That's what we figured out in this one. Thank you for watching.